Hey guys, welcome back to MathsCube. Today we are going to the third question from the International Advanced Level Mechanics M1. So without further ado, let's get started. The question is, it's a bit long one. A parcel of mass 20 kg is at rest on a rough horizontal floor. The coefficient of friction between the parcel and the floor is zero point 0.3, which you can say mu. Two forces both acting in the same vertical plane of magnitudes 200 Newton and T Newton are applied in the parcel. The line of action of 200 Newton forces make an angle of 15 degrees with an horizontal, and the line of action of T Newton force makes an angle of 25 degrees with the horizontal, as shown in the figure 1. Don't worry, I'll mark these out and I'll label them. The parcel is modeled as a particle P. Find the smallest value of P for which P remains in equilibrium. Now to solve these kind of questions, what you do is basically you resolve all the forces you can see, horizontal and vertical, so consider them. Or you can even consider the direction, where the direction goes, if it's on the right side and something is on the left side, so it can be used as a minus sign. So these directions are important. So they say that first what I'll do is I'll just solve the vertical forces, that's up and down. So I have, you can say, when we make or construct an angle here, there will be 25 degrees but sine. So the straight angle will be sine and the horizontal angle will be cos. Remember, the normal contact force always acts upwards. So you can, what you can do is just mention an R here. There you go. There you go. The vertical forces you can see on the component R plus 200 sine 15 plus T sine 25 equal to 20G. Now, why did I set 20G equal to that side? Or you can say because 20 kg or G, basically F equal to ma. So you have to add a G there as gravity acceleration due to gravity. Now, because this force is downwards, it's acting downwards, so that will be minus sign, so I'll set it equal to that side. So that will be our equation 1. And now resolving horizontal component, remember that the coefficient of friction between the parcel and the floor is zero point 0.3, not in the vertical area, so don't add mu there. There you go, that's our horizontal component. 200 cos 15 minus t cos 25 minus f equal to 0. Now what I'll do is I'll just tell you what f is in terms of r, because we have to show mu in terms of r only. There you go, f equal to 0.3 r. Now guys, to find f or to solve the second or the horizontal component, you can see there, what we'll do is we can solve for r on the first equation, that's the vertical one. Then we can find f and we can easily find the smallest value for t then. Or we can either set them to simultaneous equation, or what basically you can do is you can take this 200 sine 15 here and this 20G, or just subtract 20G by 200 sine 15 or take it to that side and make r and t the subject, because r and t are the variables that have not been found yet. There you go, r plus t sine 25 equal to 144.236191. Now do that same thing for the second equation, and taking 200 cos 15 or t cos 25 minus f to that side to make it a positive subject. There you go, I made t cos 25 plus f the subject, and that's equal to 200 cos 15. Now if you can see that f equal to 0.3 r, so what we'll do is we'll take f and replace it with the r you can see, so that can be solved in a new terms. There you go, I replaced f with r, that's 0.3 r. Now what I'll do is I'll just take the numeric value of 200 cos 15, just plug into your value and you get 193.19. Taking two decimal places, I'll set that to one equation as well, and now it's r plus t sine 25 equal to 144.24. Now what I'll do is make t sine 25 in the first equation as a subject and t cos 25 as a subject in the second equation. Here we go guys, I made r the subject, that's r equal to 144.24 minus t sine 25. Now what I'll do is I'll just take this r and plug it here, that's 0.3 r, and let's see what happens. Here you go, I get t equal to 0.78. That's when we subtract cos 25. Previously I had t cos 25, right? So cos 25 minus 0.3 into sine 25, and we get 0.78, and that's equal to 149.7. That's from 194 minus 43.3 when we multiply 0.3 by the first equation we got, or we set r as a subject. So there you go. Now what I'll do is I'll divide 0.78 from both sides, and our final answer will be T equal to 192 Newton. Or what you can do is our original answer was 191.923. So you just round it off to one decimal place and you get 192 Newton. And that's the smallest value of T for which P remains in equilibrium. And I hope you like the method. And so do subscribe and stay tuned for more videos from this series.